we're talking about linear equations in two variables. Guess what our two variables are? Yeah, and if they change them on the iLearn, x comes before y, right? So if they put on the horizontal axis that's p and the vertical axis is q, it would be p comma q. Okay, so make sure you look at the axis. So it's an equation that contains two variables. Two different variables. So when you plug x and y into an equation, it makes it true. Do you guys remember when we did problems like this? X plus 4 equals negative 8. And we subtracted 4, right? And we got x equals negative 12. Remember substituting that in to see if it's true? It's the same thing. Now we're just having x comma y. Okay? So it's a set of all points in a coordinate plane that represents all solutions of the equation. What word do you see in the word linear? And don't tell me ear. What word do you see in there, Tessa? Line. So a linear equation is the graph of a line. So function form is an equation solved for y. So it says, tell whether 5, negative 1 is a solution of x minus 3y equals 8. Okay? So when you're looking at this equation and you're trying to tell, is it a solution, you have 5, negative 1. 5 represents the, and what's the y? Negative 1. We just plug this into the equation. So I'm going to put 5 in place of x. So we write 5 minus 3 times my y is negative 1. And I want to know, is that equal to 8? So this is testing a point to see if it's a solution. Well, that's going to be 5 minus negative 3, which becomes 5 plus 3. Is that equal to 8? So yes, it's a solution. Okay? So we have x minus 3y equals 9. We are going to put this into function form. Function form means that it's solved for y. Is y by itself? No. So what we need to do, since they are subtracting 3y, I'm going to change opposite on this. Because if you don't, you will lose your negative. Okay? So we want to get that negative 3y by itself. How do I get rid of x on the left-hand side?
By subtracting it and putting a negative x on the right-hand side?
We're going to subtract x on both sides, right? Now, these cancel out, right? X minus x, they cancel, and I'm left with negative 3y equals, on this other side, I always want the x in front of the number. These are not like terms, are they? Minus x is the same as negative 1x, isn't it? So I'm going to write negative 1x and then put plus 9. Are we done? Do we have y by itself? What do we do now? What do we do now? Tessa? How do I...
Subtract 9 on both sides.
No, we want y by itself.
So add 3 on both sides.
What are they doing to these two?
Getting y by itself.
But what does that mean when it's negative 3y? They're sitting by each other, so it means they are being...
Multiplied.
How do we undo multiplication?
Divide.
We're going to divide both sides by negative 3. When I do this, you guys, you have to divide every single number in there by negative 3. Okay? So these cancel out, leaving me with y equals, this negative divided by that negative becomes a, and what fraction do you see there? Jackson? What? 1, so I'm going to write that as 1/3 x plus, what is 9 divided by -3? This is now in function form. So did you plug in number 1 like this? 2 times 0 minus -5 equals 5. Well, 2 times 0 is minus a negative becomes, is that true? So yes, it's a solution. So 2 times 3 minus 2, what do you do first?
Multiplication.
What do you get?
6.
6 minus 2, is that equal to 5?
Yeah.
It's not equal to 5, so is it a solution? Not a solution. You guys are going to spend a lot of time for the rest of your math career working on this kind of stuff. Let's take the same equation, 2x minus y equals 5, and put it into function form. We want to get y by itself. What do we do first? Alex? Yep. And what number is that in front of the y, Alex? 1. What do we do now? Jack?
Subtract 2x on both sides.
Are these going to be like terms over here on the right? No. So I'm going to put the negative 2x in the front. Do you hear me? Hello? Make sure it's in front. Am I done? What do I do now? What do I do now? Sam?
Divide both sides, no, wait.
Yes.
Yeah, divide both sides by a -1.
And you've got to do it to every single term in there. So these cancel. Sam, what's y going to equal?
Y equals 2x plus -5.
I'm going to graph the linear equation y equals -x plus 1. Is y by itself? It's already in function form. So what we need to do, we're not making a table like this because you guys have to show your work. This is called a function table. What are the inputs called? Because it's the domain, we are going to pick our own x's. Okay, I like to have a couple negatives and 0 and positive. So I'm just going to do -2, -1, 0, and 1. Now, we put the function rule right in here. The function rule goes in here. And that is whatever y is set equal to. Well, look at y is equal to -x plus 1. That's the function rule, whatever y is equal to. When we plug in these values, we get a y value back, which then gives us an ordered pair. We would have the x that we used here, and then we would get the y out. That gives us an ordered pair. So what I need to do is just plug in to this function rule. Well, that's a -1 in front, isn't it? Hello? So I'm going to go -1 times my x is -2 plus 1. Well, order of operations say to multiply first, and you guys are going to show me this. 2 plus 1, which is, that's my y value. That is now my range. So my domain there was -2. I plugged it in and I got 3. That is going to be a point on my line. Plug in -1. So I go back up to my function rule. -1 times my x is -1 plus 1. -1 times -1 is 1 plus 1, 2. That gives me the ordered pair. -1 I plugged in and I got 2 out. What do you get when you plug in 0, Jack? Jackson?
-1 times 0.
Which is?
0.
Plus 1?
1.
There's your range. So what's my ordered pair? Jack P? Jack? 0, 1. Do you guys notice? Do you see this here? Is that a pattern? It needs to follow a pattern. Plug a 1 in. So you fill out your function table, and then we are going to plot those 4 points on our graph. So when I plot those points, I put in -2, 3, which is right here. -1, 2, which is right here. 0, 1, which is right there. And 1, 0, which is right there. Doesn't form a line. So you're going to connect them with a straight edge and put arrows on the end. That is the equation y equals -x plus 1. You can see the slope. You guys said it's negative. How many am I rising? 1. And running? 1. So it's -1 over 1, which is -1. Right? I heard some of you saying 2 over 2. Isn't that same as -1? All right, these next two problems, it says we want to graph y equals -2. We're going to do that one first. Y equals -2. Do you guys notice that there is no x listed there? I don't care what x is. Give me an x.
3,
Comma, what's my y have to be?
-2.
Let's say I want to use 1. What's my y going to equal? -2. What if I want to pick 0? -2. Plot those points. It does, so we draw the line. What kind of line is that? What's it called when it's this way? Horizontal. What's the slope of a horizontal line? That one has a slope of 0. Okay, the next one is x equals 3. Notice that there is no y here, right? I don't care what you use for y. Every x has to be what number? So I'm going to pick 3, 0. 3, give me another y. 2, give me 3 and give me another. 4. Plot those points. What line is that? What's the slope of a vertical line? Undefined. I want you to write 3x minus y equals 2 in function form. Put it in function form. We're going to keep change opposite. Seth, what number's in front of that y?
1.
Then what do we do? Then what do we do? Kobe?
Subtract 3x on both sides?
And Kobe, on the right-hand side, are those like terms?
No.
What number do we want to have in front?
-3x.
Yep. Are we done? What do we do now, Carson?
You divide -1 on all of the numbers.
Excellent. And we get y equals, what do we get? What's -3x divided by -1? Plus -2. This is what we will use in our function table. So what we need to do, make a function table. I'm going to tell you the x's to use. I want you to use -1, 0, 1, and 2. What's my function rule that I'm going to put in the function table? Jackson?
3x plus -2.
Yep, 3x plus -2. When I plug my domain value in, I get a range value, which then gives me an ordered pair.